So the volume is actually V minus mv, because the gas particles take up space. If we try to compress our gas, the molecules will get closer together, and eventually we won't be able to compress it anymore. So your volume doesn't go to zero. It goes to some constant, whatever we can squish it down to. And so another thing that occurs is that when the gas particles get closer and closer together, they begin to attract. When they begin to attract, they will change the pressure. Now, why does the attraction affect the pressure? Well, in number 27, we said that the pressure is related to the kinetic energy, right? The faster the particle hits the wall, the greater the pressure. Well, if these guys are being attracted to each other, they're not going to hit the wall with the same speed. It's kind of like if I'm running towards the wall, I want to hit the wall, but someone's pulling me from behind, I'm not going to hit the wall with as much force. So I'm not going to create as much pressure. So when you compress your gas, the particles are going to begin to attract each other more. It's going to decrease your pressure. How will it decrease your pressure? Well, it will depend on how attractive the gas is. And it will depend on the density of your gas. The denser the gas, the more attraction.
What does that say?
A stands for the attraction factor. So your pressure will change based on how attractive your gas is and how dense your gas is. And the density is the moles over the volume. And because the attraction is mutual, I attract the gas, the gas attracts I. The attraction is mutual. It gets squared. So instead of having PV equals nRT, it becomes P plus A n squared over V squared times V minus NB equals nRT. That is the real gas equation. It's a little bit more complicated than that one. But the beauty of the ideal gas equation is it gives us the same answer as this one. So if you plug in the same numbers, you will get the same answer. So if you get the same answer, why not use the easier equation? Why go through all this difficulty if you can just do that? So that is the reason why in our class we never use this equation. When you go to college, you'll probably have to use it. But even then, you only have to use the real gas equation when your pressure gets really big or your volume gets really small. So the answer to number 53 is at very high pressures and very low volumes. Then you have to use the real gas equation. Yep, Trevor.
If you get the same answer for the real gas and the ideal gas equations, why do you have to use the real gas when in college?
I'm sorry, I meant in college you'll do some experiments at high pressures and low volumes. So you only have to use the real gas under those conditions.
Okay.
When you get to college, you'll do some experiments that are under those conditions.
Okay.
We won't. So, and even in college, you don't use it very often. Most of the time, you're still using the ideal gas equation. Yeah, Britta.
Why is it high pressure?
So when you have the high pressure, the molecules get very close to each other, so then they'll start attracting. And then it will affect your pressure.
So why does it make it act more like ideal if they're attracted more?
If they're attracted to each other, they act like real gases.
Oh, okay.
If they're not attracted, they're acting like ideal gases. If we were to graph our real gas, V versus 1 over P, the graph looks identical, except when you get to very low volumes, then the graph begins to curve. And eventually it will hit a plateau. Because eventually you can't squeeze your gas anymore, because it's turned into a solid. This portion of the graph looks identical to my ideal graph. We call this the ideal gas region. So here, in this region, you're going to use the ideal gas equation. When you get to very high pressures or very low volumes, then you have to use the real gas, which thankfully is not very often. Now I'm going to give you an extra credit assignment where you can have fun using the real gas equation. It's difficult. You don't have to do all of it.
When's it due?
It's due the day after Memorial Day. And these points I will just add into your score. So this will raise your grade more than chem points, because this is going right into your...
What does that mean?
So I just, like, this is worth 16 points. It will just be added onto a score.
Oh, so like if I have like 5 points off a test, so just
Yep.
put the extra points.
Right. So this will benefit your grade more, but it is a lot more difficult. In the past, I have had trouble with people copying. I don't want one person doing this and then everybody else copying it down. So you must work on this individually. And I want a signature stating that you did. Whether from a teacher or a parent or a guardian, that you were witnessed working on this by your lonesome. Now you can get help from me, you can get help from a math teacher, you can seek help. I just don't want you seeking help from each other. Because what ends up happening is one person does it and then everybody else copies it down. So if you choose to do this, I want a signature. Now I can tell you that everybody in this classroom is capable of doing numbers 1, 4, and 5. Because all you have to do for 1, 4, and 5 is just plug numbers into this equation. It's an ugly equation, but you're all capable of plugging numbers in a calculator. 2, 3, and 6, however, ask you to solve for V. There's a V, there's a V. In order to isolate V by yourself, or V by itself, you'll have to do some algebra, and it'll end up being a trinomial. Now you know with a binomial, you set it equal to 0, and you solve for it using the quadratic equation. But if you have set up a trinomial equal to 0, the only way you can solve a trinomial is actually use a computer or a calculator to solve it for you. So for those problems,
On a graph?
yeah, on a graph,
Okay.
you'll actually have to use a computer and or a calculator. You can't solve it using your own brain power. So that's why it gets kind of difficult. There is no trinomic equation. Be cool if there was, there isn't. So, but it's due the day after Memorial Day. So, why don't you put that away and let's continue on with the problems.
Where do chem points go?
Those can give you extra credit too, but this assignment will give you more.
Oh, they just raise your grade like a percentage? Okay.
Yes, right. It's a percentage at the end of the year.
Do those,
Oh, and don't forget, we have our party on Friday.
do those, like, homework passes count for anything?
Yep, 50 chem points.
So if you have 2, that's 100?
Yep. And that raises your grade 2%.
Total?
Total.
Go over 100.
Can't go over 100 in quarter 4. There is no quarter 5. Okay,
So you can only
well,
raise your
for
grade-
most of you.
You can only raise it 2%?
Yep, max is 2%. There's always some people on a 5-year plan, Nick. Okay, number 65. Let's do that one because it's a little bit trickier. Could you read number 65 for us, Ms. Nestler?
The chemist collects 372 centimeters cubed of gas over water at 90 degrees Celsius and 111.0 kPa. What volume would the dry gas occupy at 2 degrees Celsius and 98.0 kPa?
Okay, so we have a volume of gas at 372 cubic centimeters. We have a temperature of 90 degrees Celsius. We have a pressure of 111.0 kPa. They want to find the new volume at a new temperature and a new pressure. The new temperature and pressure are 2 degrees Celsius and 98.0 kPa. Now this problem would be a lot easier if it wasn't collected over water. If it wasn't collected over water, we could just use the combined gas law. We have a P1, we have a V1, we have a T1, we have a P2, we have a V2, we have a T2. We just use that. But unfortunately, this thing is collected over water.